Hello everyone, thank you for joining us today. We're so excited to have you on our fifth episode of the Baking and Military Educational Webinar Series hosted by Spet Technologies. So just a small reminder to tell more about ourselves, who we are. Spet Technologies is one of the 8 companies brands that make up the KPM Analytics holding group. And the aim of this webinar series is to share with you, with the millers and the bakers, and in general with all people who are involved in the grain industry sector, with certain keys, knowledge and experience when we're talking and thinking about the dough and flour quality control. Before getting to the heart of the matter, I will give you some practical information about this webinar. For those who don't know me, my name is Hanna Zhigunova. I'm food and application specialist and Spet technologist based in Paris. And on behalf of the entire team, I will be a speaker for this webinar. So this presentation will last around 30 minutes, after which I will try to answer to all your questions. We'll also take the questions in their Zoom question and answer feature, so don't hesitate to ask questions here. We will be happy to answer you. And if you don't have any time to ask questions today, or if you don't have any questions, no worry, you can just send the mail and we will try to respond to you as soon as possible. One final point, this webinar will be recorded, so you will soon receive a link to access to today's recording, so you can revisit some missed points or interesting things in more detail, and for example, to share this link with your colleagues or with your friends or with the people who will be interested in. So these were a few organization points, and now without further ado, let's start. Today we'll talk about mixing, how to master a key step in the baking process. And the objective of this presentation is to make as simple as possible, is to come to basics very rapidly, to understand what is the mixing, how does it work, what is that function, and what are the issues related to the mixing. How to know also if the dough is well mixed, if it's not over mixed or not under mixed, and what happens. So finally, we will try to give some ideas, give some solutions and tools to help you to check that your dough that you have made in the end of the mixing is in accordance with all your specifications, and that will allow you to continue your baking process without any particular difficulties, and will help you to obtain a final product in accordance with your know-how and your requirements. Yes. We can tell that baking is very versatile process, because if you are producing bread, bone, sandwich bread, or patisseries, the process will be of course different in order of the recipe, equipment, for example, different mixing machines, different oven, process that will be not the same, production lines, different temperature, different baking time, something else. Despite this, no matter product that you will make, the main steps will remain the same, and we can find them in any baking process. Starting with the selection of the ingredients, for adding yeast, water, grain, for example, and other ingredients, in order to homogenize them. After resting, for example, if there is this stage, after that will help us also to develop the gluten network. After the mixing process, after we'll have the rising process, so it can be 1 or 2 process of the rising, for example, before shaping or after shaping. It will really depends on the process and the your final product requirements, but this stage actually will be present. So after the rising stage, we'll also have the shaping. Yeah, so it will help us to obtain the product that we want. For example, it will be more elongated for the baguette, more round for the pizza, small or big in form of croissant or whatever product. So once the dough patties will be formatted, the dough should be cooked, of course, to make it edible, make it consumable. And after we'll have a cooling and consuming the phase. Okay, to sum it up, of course, all baking processes are different and depend both on manufacturer and on the desired finished product. But still, we can find these main steps everywhere, like mixing, fermentation, shaping, and baking. And despite of these stages, there is the first stage that is very important and that we will be focusing today, and this mixing. This is very important. Why? Because this is like an engine, like a factor that has a big impact not only on this step, but also on others baking process. That will lead also to the different final products that it was expected. So it needs to be controlled to ensure that the process will run smoothly and the final product will meet the expectations. As I already said, the mixing stage, if it has been made successfully, following all the conditions and the rules, and for example, observing all the parameters like water absorption capacity, dough temperature, etc., it means that almost half of the work has been done, which will ensure that your process will run smoothly without any big issues at line, and in the end you will have a good dough that will match the expected final product. Now let's come back to your kitchen. What we need to do to make a dough. Okay, so let's take things simple. What we need? Of course, it will be addition of the dry ingredients like flour or sugar, salt with water. And of course, it will be the application of energy to form this dough with the texture and consistency that meets your expectations. Of course, it will depend kind of product what we want to achieve and under what the conditions we will make it. We will get more or less elastic, extensible or stretchy dough. And the characteristics of the dough will be quite different depending on the product and on the method of making the product in the bakery process. If we try go over the details on what is the function of the mixing and what is the objective of forming the dough during mixing, it will be multiple. At first, it will be combination of all ingredients to make a dough, like liquid ingredients, for example, butter, oil, and for example, the dry ingredients like salt, sugar, etc. So that is the first phase of homogenization of these ingredients. The second phase will be addition of the water, which will permit us to make a structure, to create this cohesion between the ingredients, and to obtain the dough with the consistency and characteristics that we want. Another point of importance, this is often to tend to neglect, this is the aeration. It is a very important phase in which one of the development of the future alveolus will take place. The importance is that at this stage during the mixing, we will add air to the dough, so we will disperse air cells that will incorporate the air into the future alveoles that will be developed during the fermentation stage. And clearly, in absence of the inclusion of the air in the dough during the mixing stage, you can produce during the fermentation the all CO2 that you want, but the dough will simply not rise. Therefore, it is very important to have this nuclear air that will create these alveoles and consequently make the dough rise. And of course, all the stage like incorporation of the ingredients, creation the gluten network, incorporation of air need the energy. Principal mechanical energy to mix to create this set of elements in order to form the dough. As we saw and as I told you about the function of the mixing, the aim of it that we will seek a certain consistency at the end of the mixing. And thus we will have the different conditions. So it's pretty logical. the quality of the final product will depend on the quality of the mixing procedure. For example, if it will be the dough for the croissant or for the cookies or for the sandwich bread, for baguette, it will be different mixing process. But sometimes what seems more complicated is that one product, as here we have the example of the croissant from different countries, from Ukraine, from France, from Italy, from Greece, that depending on the country will have not the same impression of what is a good and bad croissant. For example, in France, the croissant will be less or more puffier with their good structure. In the Greece, it will be less high in the volume of the croissant, and it will be different specifications. And the more interesting things, even in one country, the one producer or another one, they will have different croissant between them. It will be not the same product. Consequently, depending on the type of product, the mixing process will need to be adapted. Need to be adapted to what we want to really achieve. And that is why it's quite rare that we can find one type of mixing identical that will work for the desired product everywhere. This all said that it will necessary to come to anticipate and adapt and manage the mixing process, and to find the optimal one that will be adapted and to each need, to each product, and of course the each production line. As you see, this stage of mixing is an important stage. But the question is, what happens if we are undermix the dough? If we start with what we can find in the literature, globally, if we undermix the dough becomes more stiff, too elastic, which will show itself to be really hard. And it will give a bad consequences on the production line because it will be difficult to add it in the mold to the form. So the dough will be also the cooler. What does it mean? It doesn't mean that the yeast will be present in the dough, will work less slowly, and it will produce less carbon dioxide that will affect the proofing. This will not happen if the dough is kneaded optimally. Consequently, all of these problems that we can be faced in the unmixed dough will be present in the final product. So, for example, like low volume because, for example, of the poor gas retention as the final development of the gluten network didn't occur, or denser and firm crumb of the poor air incorporation, or if the dough was not so mixed, the gluten frame will not have time to form, as I already said, and the result, the dough will rise poorly and the breadcrumb will not form. So there is a lot of different things that can happen. You will not undermix or not mix optimally the dough. Okay, so in reverse, if we give a lot of energy and if we overmix the dough, we will absorb the dough too wet and sticky. That will lead to issues with its elasticity, process difficulties. For example, the dough will stick on the production line and it will be really hard to handle the process. It will proofs at a faster rate. Yeast activity increases with the temperature. And one more time, all these impacts on the dough will be detected during the final product. So we will have several consequences at the dough with the pure symmetry and sexy volume and big crumbled holes. So it's a big alveoles. And of course, it will be not conform of what we want to expect. It will be not conformed by the producer and by the consumer itself. All of this just to tell that we need to find these optimized settings, and overmixing and undermixing can affect not only other baking processes like shaping, proofing and baking. After, it will also affect the final product. Okay, so the question is that how to control mixing? Do we have any parameter that influence on mixing process? And the question is yes, of course. Regarding of the literature and the knowledge that we have, there are several parameters that can influence on mixing process, which will lead to several consequences. One of them, for example, is this type of mixer. Depends, I don't know, maybe its mixer is very powerful because of the shape, because of the mixer speed. It's spiral, horizontal, high speed, low speed, continuous. There is a lot of that can be affect the final product. Another parameter, it would be the water that you add. If you add less or more water, you will end up with a different consistency of dough, which will behave differently. Same for the temperature. Mixing is an intensive mechanical operation that produces really heat from the friction. So this evidences by the temperature increase, the mass will be transformed in the dough. That means the dough will be more cold and more hot. And actually this will influence after or during the fermentation process because of the different yeast activity. And another parameter that will influence, of course, the quality of the flour. It will affect not only the mixing time, but also we will have the formulation that will be affected. For example, the addition of the salt, the addition of the sugar or fat. It will also may have some consequences on the mixing process. So we need to control it. So these are the major factors that can affect mixing, but there is more others, for example, like environmental, operation, and etc. That means that by not controlling these all conditions, we can have also undesired final product in the end. That means that the mixing is not so simple as we were thinking about. It's not just mix the water and the flour. It's also to control the other parameters. So it depends on these factors and mixing procedure, the dough we will obtain will be conform or not conform to our requirements. And here we begin to ask the questions. How do we make sure that the dough that we get in the end of the mixing will correspond to what we want? And what you can see, the guy started to touch the dough. He will evaluate manually the consistency of the dough, and further he or she will evaluate tenacity of the dough and other parameters. So that meaning this operator finally will assess that the dough is conform or not conform what he expects, whether it means the desired quality or whether it risks of encountering some difficulties. So this is manual evaluation, and it's very limited. Why? Because it's sensor evaluation, where the person doing test and will judge his work by himself. It's extremely subjective, because for one operator will be good, for another will be not. But even for one operator, if his day passed not good, or it passed very good, or he's feeling good or feeling bad, it will influence on the final result. So where to find this middle and to make the correct conclusion? That's why there is a people expert who has 10 and more years of experience that will check it. But what happened if they will be betrayed, or if they will change something, or if they will leave the company? We will lose this know-how, we will lose this experience. And we again need to start from the beginning to formulate the specifications. Another reason that this kind of their testing is long, it's costly, so it's taking time. But the most important thing is manual control help to see what is happening, but not giving information on the reason behind. For example, we see the guy, he's touching the dough, he's like, okay, it's sticky. But why it's sticky? From where it comes? Is it because we add a lot of the water? Is it because of the mixing, or is it about because of the temperature, or because the another parameters? So there is limited understanding of that. So we can see the manual control limits the qualitative control of the dough. So what to do then? How to improve this method? How to improve this manual evaluation? And we have the answer for you. We have the proposition to control the mixing process with objective analyzers. So the principle will be almost the same. You need to take the piece of the dough and to test in the end of the mixing process, but not by the sensory evaluation, like by touching the fingers. You can do it, of course, but also thanks to other equipment, rheological equipment like MIXOLAB, ALVEOLAB, and RHEO that will help you to make a good conclusion. This is what I will try to detail and to give you in few examples in the few slides. So what we saw that we need to have the kind of the strategy to analyze the dough. So first of all, what we will do in function of the device, we will take a sample, for example, of the dough at the end of the mixing. After we'll put the sample into the rheological device and we will analyze. Like that, we will compare the results with our specifications that we already created to be sure if this product is conform. For example, if we have good dough, that means that we will have the good product. Or if its product is not conform, for example, we will have bad dough and we'll have finally bad final product. So we have this strategy, and I will try to give you some fast examples to show this idea. So the first parameter that we will want to control during the mixing is, of course, the dough consistency. So this is what operator will be touching by the fingers, and he will be evaluating this consistency by himself, if it's conform to what he's expected or not. And one of the devices that will help to do that is MIXOLAB. For who don't know about the MIXOLAB, MIXOLAB is a recording mixer that measures rheological dough properties and predicts the dough behavior during the cycle of the mixing, heating, and cooling. If you need more information about this device, you can contact us at kpmanalytics.com. Also, you can go through our website. We have different solutions, and or come just simply to come back to us, and we will be happy to answer to all the questions. So if we will come to our MIXOLAB and how it works, so we'll take a piece of the dough at the end of the mixing, the end of the mixing of the industrial mixer, we'll put inside the machine, inside the MIXOLAB in this case, and we'll start to analyze it. So in the end, we will have kind of the information, so it depends, of course, of your protocol and what you want to achieve. And we will compare with our specification, if this product is good or if this product is considered like bad, not confirmed. I will try to illustrate by few examples. So this is an example of a Dana's producer that analyzed the line of production and they find to obtain good consistency. Because at his production, he has a lot of fluctuation during the process and he didn't know from where it's coming and he wanted to control it. So he made some few analysis and he considered that a good donut requires dough with consistency ranging between 0.69 millimeters and 0.8 millimeters. So this is MIXOLAB parameters. And he found that, for example, if we are out, so if we are up or if we are down, in this case we are up, this consistency, that means that we will have in the end bad dough, so the dough is not conformed to our specifications. That will lead to have the bad final product. And if the dough were inside, the dough tests were inside of these target profiles, we consider this dough like conform, so we had good dough and good final product. And we can see that thanks to the MIXOLAB, we can anticipate any fluctuations in donut quality and later and closely related the dough behavior during the production and very rapidly gives an idea, an objective idea about the consistency that will help us anticipate if the dough is not good fermented, to add something, to change something, or if it will be leaded to other problems on the lines. So everything we can anticipate before. Okay, so another very interesting example that often to produce the same product, it can be done on the different product lines. And we can tell that we're thinking, for example, you will mix all the ingredients, we will have the same mixing process, it will be enough to get the desired product. And with the time, we can understand that it's not like that. And this was the case of this producer. This factory had the two different lines. And the aim of the, of course, of the production was to get the same final product in the end. By analyzing in our equipment, they found that the dough on the line A and line B, it's giving not the same results. That means that we consider that the same product can be different a little bit in the end. For example, if we can see the dough at line A, it's more tight, it's more resistant to the mixing than the dough on the line B. And this will give an idea to this producer and that each line and each process is unique. Like that, thanks to MIXOLAB, he could adapt his process, or adapt his line in order to get the same final product in the end. This is the proof that each line, each process is very unique. And there is a need to control individually each tool of the production and to make regular control. And thanks to the devices like that, we can do it and we can adapt to the task in order to control dough consistency throughout the process to get consistent quality product. And also, where possible, to control different formulation. Last time we can observe a big tendency and interest to gluten-free products and also to the people who are sick on celiac disease. That's why there is interest in it, and we have some solution. So, for example, how we can control different process, for example, with the different pastry recipes. Depends on the oil or if it's butter inside, and etc. And is it possible to do with the MIXOLAB? And our answer is yes. We have tested 3 gluten-free recipes with the protocol. It's a little bit different, but we will focus on the mixing part for today. So we can conclude that in the first function of the different recipes, we have not the same response. We have the broad range of behaviors. We have different development time, different stability, different maximum torque that will permit us to control and to create specifications for each recipe and anticipate baking process. And that means that MIXOLAB 2 is perfectly suited to assess these mixing properties of gluten-free products. And on that example, it can be tested with the, for example, reduction of the sugar or salt, or addition of it, or other formulations as you wished, in order to create the specifications of what you want to achieve in the end. We have seen up to now the kneading phase or mixing phase is very important, and that the consistency of the dough after mixing is a key step. But the thing is that depending on the mixing characteristics, viscoelastic properties of the dough will be impacted. So this is what we see that the men were touching with the fingers and tried to stretch the dough to see if it's extensible, if it's elastic, if it's tenacious. So he started to look on this compartment, and we can have a conclusion that the shaping has a very particularly sensitive step, or that will have their different consequences. So the ability to stretch, elasticity, and so on can be analyzed by the equipment that we are proposing, and this is the MIXOLAB. I think you're already familiar with this equipment, but let me tell it one more time about this. The principle, it's really simple. So you need to form the dough. After you will cut the small pieces, you will add air, so you will blow a bubble. And depending on characteristic of this bubble, you can characterize the dough with your viscoelastic properties like tenacity, baking strength, elasticity, and extensibility. So now I will give you a small example that will help you to understand better. Just before we start, I want to tell you that we are in the research stage, so we haven't fully optimized this method yet, but we were confident to do that in the near future, and we will communicate, of course. So the idea is to try once again to take a piece of dough, to put in the machine, analyze it, and conclude one again if the dough characteristics are conformed with our specifications or not. As already told, we are in the research stage and that we have already tried several tests showing these results. So we have conducted that experience. We tested 4 different protocols with the mixing time 6, 8, 10, and 12 minutes. And we got our results on the MIXOLAB, and we can conclude that depending on the mixing time, we can have the different viscoelastic parameters which will conform different behavior of the dough. Globally, the longer we mix, the more we reduce the extensibility and the more we reduce the consistency of the dough. So we've seen the importance of the consistency, of elasticity, extensibility, tenacity, so of the all viscoelastic parameters. But I mentioned in the beginning, in the first few slides, about the impact of the mixing on the proofing, if the dough is really cold or it's very hot. And the quality of mixing procedure will have significant effect on the proofing process. If the dough has not been mixed well, or if it has been undermixed, overmixed, the effectiveness of the yeast will be affected during the proofing. The dough will have not the same characteristic, and consequently it will affect the final product, as like crumb structure or a volume. So for example, if the yeast will work differently, we will produce not the same production of the gas that was expected. And if the dough has not the viscoelastic properties that is wanted, as tenacity, extensibility, or elasticity, that means that the dough will have not the same ability to retain or not to retain the gas. And finally, we will have the different bread volume. So for this kind of the task, we have the equipment to propose that will have a complete overview on the proofing characteristics. So the principle is really simple. We will need to take again a piece of dough, we need to put into the device, and we will let this device develop with the time. And in the end, we will have the result that will help us to have information about the dough development, about the gas retention and gas production. So we'll take the dough, we'll put in the RHEO, and we'll see what we have. We made again with a small study that will show us that globally, depending on the mixing time, 6 or 8 minutes or 10 minutes, the response in order the proofing fermentation will be not the same. It will be different. So if we were mixing more time, the final volume was a little bit high, and the gas production and the gas retention was different. That produced more and more retain the gas. So that's why it gave us an idea of the future volume of the finished product. So these were small examples showing that there are tools that can help to objectively and instrumentally assess the quality of the dough, especially to assess this quality in the end of the mixing, because this is the key to ensure that the baking process will pass without any fluctuations, without any difficulties, that will help us to obtain quality of desired product. And it will conclude all of the reason of the collapsed top of the bread, inconsistent crumb, poor symmetry, great low volume, big cracks, and etc. It's led to undermixing or overmixing. And it has a very huge economical impact also. And it will influence on the final product and consistency. And the thing is that we not only need to measure the mixing, okay? You will have the mixing has the consequences on the other process like their shaping and fermentation. We will need to have also to check it before put the product on that steps. And for that we have adapted solutions at your disposal. As I have already mentioned, this of course our three top devices, MIXOLAB, RHEO, and MIXOLAB, that will help you with that. And then as we are in the mark of the KPM analytics, we have also another solution for you. This is a solution more for the quantify objectively the final product, because this is the key also of the successful production. So for example, what are the parameters of interest that need to be checked? If it is volume, if it's the shape, or it's something else, how to objectively quantify if its product is compliant, how do you ensure that your consistent product quality across batches, across teams or sites, how can you save costs and reduce losses to improve your business results? And a simple and effective way to do that is to use the Bayesian equipment like iPro and SiteClimb. So if you're interested also, don't hesitate to come to our website or ask questions. We'll be happy to respond to you. So we have a range of products to help you mastering the production. And depending on what you are searching, what is your objective? This is what I'm telling every time. You need to understand your process. You need to find your process, your specifications. When somebody is asking us, what product is good for me, what is good croissant, we're always telling it depends on you, depends what you think it is good for you. Because you will check the water absorption, it is your important parameter. Is it dough consistency that you want to check? Is it extensibility, elasticity, proofing characteristics, or volume? So it depends really what you think and what you seek for that. And on your disposal, we have different equipment. Don't hesitate to come to the KPM website. We have different articles that we made this last year about different solutions for the bakeries, manufacturers of the croissant, of the flat dough, of the flat bread, or other solutions. So that's it. I would like to thank you for your attention. Just if you have any questions, don't hesitate to come to sales.kpmanalytics.com. We will be happy to answer and also to help you if you have any questions. So thank you for your engagement, and don't hesitate to register to the next webinar that we will be doing at the end of the next month. This webinar will be about the shaping. We'll be very happy to have you. Thank you again, and see you in the next webinar. Bye.